Welcome to this video on domain and range of a cubic function and higher order polynomial functions. So on the top of the screen, what we see here, we have a standard equation, a typical equation of a cubic function. So A represents the leading coefficient in three different cases. So the first one is just ax to the power of 3. Now you can see that no matter what x value you can use, there will be always a solution to the value of y. So you can anticipate no restrictions at all. Even if you change this equation and you show x minus 1 to the power of 3, there's no way that you will have any limitation as to the selection of x value is concerned. So you can gradually see that domain for any cubic function should be a set of real values. So the domain has no restrictions, and we can say that x is element of R, and that's the domain. Okay. Now, in terms of the range, so this blue curve represents a cubic function with 3 x-intercepts. So x-intercept, we can call them also root 1, root 2, and root 3. So this is why you see x minus root 1, x minus root 2, x minus root 3 here on the screen. So this is a very general type of equation that defines a cubic function. How do we know that this is a cubic function? If you were to expand and multiply those brackets, all of them together, so you will get a in front, and then you have x times x will give you x squared times x cubed. So yes, this is an example of a cubic function. So recall the equation of a line. So the degree of a linear function is 1, and I quickly will recall this as mx plus b. So the exponent of x is 1. Now the exponent of x is 3. A straight line has no limitation in terms of its range, and so does the cubic function. So there is infinitely many values of y without any interruptions that you will get by using any real value of x. So the range will be all real values and no restrictions. So the range and the domain is very much the same as for a linear function. Now, the bottom of the screen, you'll see that there are examples of a function, polynomial function, where the exponent of x is 4. So this is a higher order polynomial function. When the exponent is 4, we call it a quartic function. So as with the cubic function, there should be no restrictions for x values. Any real number can be put to exponent 4. So that's a given. This is what we can intuitively understand without any suspects that there should be a problem. When you have a number, you can put it to exponent 4. Positive number to exponent 4 will result with positive value. Negative number to exponent 4 will also give you a positive reading. So let's say negative 2 to the power of 4 will give you 16. Positive 2 to the power of 4 will give you also 16. So the leading coefficient a, like with quadratic function, basically is responsible for the opening of that polynomial quartic function. So we call this in general, quartic function we call it as W type of functions because more or less the graph of that function should resemble a letter W, which means when a is greater than 0, the opening is up, or the end behavior of this function points up. That means, which is very important for the domain, for the range, I will have two vertices at some point where either they at the same height below x-axis, or one is lower, one is higher. So let's say this one to the right, the vertex represents the minimum value, the lowest possible value. So that means this is the reading on the y-axis that is the lowest. So from that point on, any other point on the graph should give you slightly or significantly larger value of y, which means the range will be related to the minimum value and will be beginning from that value up. Similarly to a quadratic function, when you have one vertex and everything either starts from this vertex going up or going down. So when the leading coefficient a is greater than 0, a is greater than 0, my range will have limitation related to the minimum value. So you will have a set of real numbers. Y is element of R such that I have to rewrite this in better form. Just give me a sec. So Y is element of R such that Y is greater or equal, let's call it K, the minimum value, K. So this is the range. Domain of this function has no restrictions, so X is element of all real values. And the minimum will be X, comma, K. So that will make sense why all of a sudden you see a letter K in the statement. Should the A value be negative, if A is less than 0, so the entire graph would flip. So if that was the mirror image, that would give you more or less graph that would have close resemblance to letter M. So in that case, my minimum value will now be considered local maximum. So this is maximum, a maximum for that value of X, and the value of maximum is represented by letter K. So the domain would be exactly the same. However, the range will be opposite to the one above. So set of real numbers of y. So y is element of R such that now y is less or equal to the value of k. Now, based on this example of a cubic function, quartic function, you may see a formula is unfolding here. So any type of polynomial function where the degree of the variable is odd, 1 or 3, then next will be 5 and 7 and so on, the domain and range is the set of all real numbers, no restrictions, no conditions. So this is true for a line, a cubic function, a polynomial function of higher degree with exponent 5, 7, and so on. In terms of quartic function, quadratic function, where the degree is even, so this is 2, 4, 6, and so on, the domain has no limitation at all. However, the range is strictly connected to the lowest value, the minimum value of y, or the greatest value of y, so where the vertex is the highest point on the graph. So the range in that case is either starting from the lowest point, the lowest value of y going up, or starting from the highest value of y and going down. So this works only for polynomial type of functions where the degree, the highest degree, is an even number, like 2, 4, 6, and so on. So this is it for that video. I hope you have enjoyed it, and I see you next time. Thank you.